Welcome to Machine Learning Laboratory, program number 5. Here the problem statement is we need to write a program to implement the Naïve Bayesian classifier for sample training data where the data is stored as .csv files. And we need to compute the accuracy of the classifier by considering a few test data sets. So before getting into the actual programs, we should know some of the basic information or background knowledge of this program. We shall see now. This Bayesian reasoning, which provides a probabilistic approach to inference, and it is mainly based upon assumptions that the quantities of interest are governed by the probability distribution and that optimal decision can be made by reasoning about these probability together with observed data. Why we need to study this Bayesian learning with respect to the machine learning? There are two different reasons are there. Okay, one is when Bayesian learning algorithm that calculates explicit probabilities for hypotheses such as the Naïve Bayes classifier. See, these are among the most practical approach to certain types of learning problems. The second reason is that they provide a useful perspective for understanding many learning algorithms that do not explicitly manipulate the probabilities. So these are the two reasons why we need to have a Bayesian learning method which is relevant to the machine learning. And we shall see, there are some features of Bayesian learning methods. See here, each observed training example can incrementally decreases or increases the estimated probability that a hypothesis is correct. Okay, so this provides a more flexible approach to learning an algorithm that completely eliminates a hypothesis if it is found to be inconsistent with any single examples. Second feature is that prior knowledge can be combined with observed data to determine the final probability of a hypothesis. See, in Bayesian learning, the prior knowledge is provided by asserting the prior probability for each candidate hypothesis, first one, and the second is a prior distribution over observed data for each possible hypothesis. Bayesian methods can accommodate a hypothesis that makes probabilistic predictions. When you have a new instance that can be classified by combining the predictions of multiple hypotheses, and these hypotheses are weighted by their probabilities. See, the last feature is even in case where Bayesian methods prove computationally intractable, they can provide a standard of optimal decision making against other practical methods that can be measured. Here, Bayes' theorem that will provide a way to calculate the probability of a hypothesis based upon its prior probability, the probability of observing various data given the hypothesis, and the observed data itself. So you can see the theorem in this notation. So here the probability of H, that is P of H, which is called as a prior probability of H, which will reflect any background knowledge about the chance that H is correct. And probability of D, again it is a prior probability of a D, that is a probability that D will be observed, and it is called as a predictor prior probability. And another term is probability of D given H, that is the probability of observing D given a word in which H holds, and this term is called as a likelihood prior probability. And the last term is the probability of H given D, which is called as a posterior probability of H, which reflects the confidence that H holds after D has been observed. See, this Bayes theorem is the cornerstone of a Bayesian learning method because it provides a way to calculate the posterior probability from a prior probability together with the probability of D and probability of D given H. There are some important notes are there that you should remember. That is, the probability of H given D increases with the probability of H and probability of D given H according to the Bayes theorem, and this value will decrease as the probability of D increases, because the more probable it is that D will be observed independent of H, the less evidence D provides in support of H. So this is the basic information about the Bayes theorem. You have to remember the major terms like likelihood term, prior probability, and the posterior probability. Here we actually going to identify what is the posterior probability value of an hypothesis for a given data set. See, in the next topic we shall try to address how to calculate the posterior probability of a candidate hypothesis. See, assume that you have an hypothesis space which is denoted as a capital H, and in that hypothesis space you have some sort of candidate hypothesis. See here, how do you calculate that posterior probability for each and every candidate hypothesis? By using your Bayes theorem. So here, when I call that a candidate hypothesis is a maximum a posterior hypothesis, how do you calculate that? See here, we are going to use this Bayes theorem here. So here you substitute the Bayes theorem here, the terms. Remember that whatever the value you have, that is probability of D, is common to all the hypotheses, candidate hypothesis. Assume that you have 4 hypotheses: H1, H2, H3 and H4. You have a 4 hypothesis. When you write a formula for this entire individual hypothesis, how do you substitute the values? That is probability of D given H1 into probability of H1 given probability of D. Similarly for probability of H2 into probability of H2 given PD. So similarly for H4 also, probability of D given H4 into probability of H4 divided by probability of D. So you can observe in each and every hypothesis, that is whenever you are going to identify what is the value of hypothesis, that is posterior probability value of each and every hypothesis, this probability of the D will be remain common, because you are going to use only the same data set for our entire hypothesis. So this term will remain same, and you are going to eliminate that term, and you are going to write only these 2 terms. In a sense, that is a likelihood probability and also the prior probability, which actually reflects or which actually plays an important role in identifying your hypothesis, which is a maximum, a probability. Assume that how you are going to get this a maximum a prior probability value for a set of hypotheses. If you have a 4 hypotheses H1, H2, H3 and H4, by applying the values of probability of D given H and probability of H for in this formula or for this hypothesis, assume that you have received some value, that is 0.1, 0.3, 0.2 and the last one is 0.4. So when you identify the posterior probability value for this individual hypothesis, you may receive some values. So among this hypothesis space, the hypothesis which is having the highest value, here you can observe that H4 is having highest value. which is 0.4, and this hypothesis is called as H map, that is H4 map. That is a hypothesis which is having a maximum, a posterior value. So this is a simple explanation regarding how to calculate your posterior probability for a given set of candidate hypothesis. See, when we call a maximum likelihood hypothesis, see, there are some cases where it is assumed that every hypothesis in H is having a equal prior probability value. So in this case, you can see the equation that is simplified, and it is needed to consider only the term probability of a D given H to find the most probable hypothesis. And this is the term that what we have received from previous equation. Here, as I said, that when you have an equal prior probability value for a set of hypothesis given D, this term remain constant for all the hypotheses. So hence this term will be removed, and the only left term is probability of D given H. Whenever you want to identify what is the maximum likelihood hypothesis, then you are going to use only one term, that is a probability of D given H. So here, if I want to identify what is the maximum likelihood of a set of hypothesis H, where you have H1, H2, H3 and H4. So here, how do I identify the maximum likelihood? So using only one term, this one. So here, probability of D given H1, probability of D given H2, similarly for probability D given H4. So you may receive some values like 0.1, 0.2, 0.3 and 0.4. So out of this probability of D given H4 having, that is foreign hypothesis 4 having highest value, so that hypothesis is called as maximum likelihood hypothesis, because here the only one term which is taken care while identifying the maximum likelihood hypothesis. Till now the Bayesian approach is used to identify the hypothesis which is having a maximum posterior value. But let's apply the same Bayesian approach to classify the new instance where you are going to assign the most probable target value. The target value which is defined by V, and that which is having a maximum posterior value which is denoted as V map. Remember guys, whenever you are going to have an instance, assume that x1 is one instance. This instance which is described with the help of the attributes. Here every instance is a combination of attributes. So here these attributes are these instance having a target value, or you can say it as a class or a category, whatever, or whenever you are going to identify the class for new test data to which target it belongs to, that is calculated by using this V map. Here V is nothing but a value is nothing but your target value. As we have already seen in the previous examples, like in program 1 and program 2, there we have studied the concept learning of enjoy sports. There you have two possible outputs are there. One is whether the person will enjoy the sport or not. So the target value is two different values, that is yes or no. So here similarly you are going to identify what is the maximum a priority value for yes and also for no by using your set of attributes. So this is your V map. V nothing but whether yes has a maximum posterior value or no has maximum a posterior value by using your probability of yes given attribute or probability no given attribute values. So we can use the Bayes theorem to rewrite this entire expressions here. So V map, by applying your Bayes theorem, you are going to identify the values of V map by just replacing the terms. Here V map is nothing but your target values. It is nothing but your entire data set which is having attribute values, and the attribute given V is nothing but a target values, and finally this actually you are going to identify V map. So here this is with the help of this formula we are going to identify which target value has highest value for a given test data based upon your set of instance values. Now we shall see how to apply your Naïve Bayes model to our program. There are three types of Naïve Bayes model. One is Gaussian, multinomial and Bernoulli. The first Gaussian Naïve Bayes model is used when the characteristic or attribute values are continuous in nature. Then an assumption is made that the values linked with each class are dispersed according to Gaussian, that is normal distribution. Second one is multinomial. See, multinomial Naïve Bayes is favored to use on a data that is multinomially distributed, and it is widely used in a text classification in NLP or ML. Each event in text classification constitutes the presence of a word in a document. And the third one is Bernoulli. See, when the data is dispensed according to the multivariate Bernoulli distribution, then Bernoulli is used. That means there exist multiple features, but each one is assumed to contain a binary value. So it requires features to be binary valued. So these are the three different types of Naïve Bayes model. Here in our program we are going to use a Gaussian Naïve Bayes. Why? Because the instance or the test data that what we are taking to analyze our model is of values which are continuous in nature. So we shall try to solve the example of a Gaussian Naïve Bayes and try to apply to our problem. This Gaussian or normal distribution depends on two parameters of a series. One is the mean and the standard deviation. So knowing these two parameters of a series, we can find its distribution function, which is in the form of this one. So why we need this function? Very simple. See, the majority of the data in the world is which is represented in the form of continuous values, but you cannot calculate the probability of x to get something or to get the value of v. So if you want to get that, the value will be 0, because when you divide something by infinite, you will get the value as a 0. So we can how can we solve this problem? Yes, by using your Gaussian distribution function. So let's see how this problem will be solved by taking a set of instances. Let's consider a training set example. So in this set of data set, there are 8 instances are there. So in these 8 instances, there are 4 male class and 4 female classes are there. And also you can see that there are 3 major features or attributes are there. One is height and weight and foot size. So based upon these values, height, weight and foot size, the class are determined whether a person is a male or a female. So with the help of these data, we'll try to solve a test data to which it belongs to based upon this training set example. So let's see that one. As we already know that these are the two important things that you should remember. One is mean and another is variance. So here we try to calculate the mean value for a height. Condition is for a class called as male. So substitute these values. So n is nothing but the total number of male instances, and these are the values of heights. So when you substitute these values in the formula, so you will receive the value 5.855. Similarly, you are going to identify what is the variance of height for given set of instances, that is for a male. So here 1 divided by 3, how do you receive? By substituting these values in this formula. So n is 4 minus 1, 3, and you substitute the value here. 6 minus 5.855, that what you have received from this mean. Similarly for the second term, second instance, third instance and the fourth instance. So you will receive the value of variance which is approximate as 0.035033. So this is how do you calculate with the height with respect to male. This is the first one. Second one, similarly you are going to identify what is the mean value and the variance value for female. So these are the values that what we receive. Similarly, we try to identify what is the value for mean value for weight given male, variance value of weight given male. So these are the values that what I receive. Similarly for weight, this is what I receive the values for the female. And the next one is we shall see how do we substitute the values for foot. So as we have three variables, one is the height, weight and foot size. We are going to identify what is the mean value of height, mean value of weight and mean value of foot. So substitute the values here in a given condition, in a given formula, and try to identify the values. And these are the values that what I have received, and these values have been summarized in this way. So there are two classes are there, that is two target values, that is male and female. So I have identified what is the mean value for male of height, and also similarly what is the variance of height given male. So when you see this one, this gives an overall summary of the values that what we have derived by using your sample mean and also variance, which is applied on these attribute values. So now I need to identify the prior probability. How do I identify? By taking the probability of male and also probability of female. See, in our case, out of 8 instances, 4 instances are male and 4 instances are female. In the sense, the probability is equally distributed. So the value for probability of male and probability of female is 0.5. So this is the formula for probability density function. So what I need to do, I need to identify the posterior probability of male and also posterior probability of female. So in order to identify these two values, I need to identify these terms. So the terms is the probability of male that I have already received, that is 0.5. The thing is, I need to identify what is the probability of height given male. Similarly with respect to weight and also food size. So how do I identify the value here? By applying your probability density functions. So in order to get these values, probability density function, I need two terms. One is with respect to the mean and also variance, standard deviation. So here, applying these two formulas, calculate what is the probability value of height given male, weight given male, food size given male, and also with the evidence. And evidence is, the formula is given here. So after identifying these two values, whichever having the highest value, that value or that test case will be classified accordingly. So here, what is the test case that have been given? The test case is I need to identify what is the class of a given instance. So here the height is 6, weight is 130 and food size is 8. So I need to identify to which class this instance belongs to, whether it is a male or a female. So how do you identify? By computing the probability density function with respect to male and also with respect to the female. So height, probability of height given male is equals to, you apply the probability density function here, 1 divided by square root of 2 into pi into this value. What is this value? Is variance. So this value is received as we discussed in the previous slide. So here 6 is nothing but your test data that is taken from this one. So minus the value that what I have received during the calculation of this one, and apply the same in this equation and you receive this value. Similarly with the weight here the major part is the test data. What is the weight here? 130 lbs. Similarly for food size, which is in the form of inches, 8, and you calculate all these values and you receive this much. Similarly, when we apply the same thing for female, here also you have received the values for female, that is you have identified what is the mean value of height with height given female, and also what is the mean value for weight given female, and also with respect to the food size, and you apply those values in this formula and try to compute that one. So you will receive this value. So I hope you have understood clearly. So now taking those values, you substitute in this formula. What is the formula here? Probability, that is posterior probability of male and also the posterior probability of female. So apply the value for this one and you receive. The evidence remain same because whatever the value I have taken, which is from that particular set of data set, and the probability value remains same. So hence I have eliminated that evidence and I just use this prior probability value and also the likelihood. So substitute these values in this formula and you receive 6.19947 into 10 to the power of minus 9, and apply the same values or whatever the values we have received for these terms in this formula with respect to the female, and you will receive these values. So when I compare these two values, so here 5.37783 into 10 to the power minus 4, which is greater than this value. So hence I predict, or we predict, the sample that is test sample belongs to female class. So this is how we compute by using your Gaussian Navier Bayes. So this is, I think you have understood clearly. So by taking this method, we are going to just apply to our program, and your program works in this way. We shall see that one. So here you can see that for our program we have taken a data set which is a FIMA Indian diabetic data set. So in this data set you have a feature set and also the outcomes or classes. So there are first attribute is a pregnancies, second one is glucose, blood pressure, skin thickness, insulin, BMI, and diabetic pedicle function and age, and these are the values of an instance, and this is the outcome, means whether the patient belongs to or the patient is a diabetic or not. This is what we identify. So by taking this example or by taking this data set, we try to identify what is the accuracy of your Naïve Bayes classifier, and we try to predict for a given instance to which class that instance belongs to, whether the instance is of diabetic instance or not a diabetic instance. There are 4 important steps are there in our program. The first step is we have to import the data frame. So the data frame which is used to store your data, which is in the form of a .csv file, I just store that entire data in your pandas, that is data frame, by using your read CSV function. And also I label my entire data or entire data set into 2. One is the column names and another is your class name. Column names are nothing but your features. So how many are there? These are the feature of your data sets. 8 feature sets or 8 features are there, and the last column is whether the patient is a diabetic or not. So I stored this entire 2 things in 2 variables. One is x and y. In x, what we store? We store the values. These are the factors which are for predictions. Okay, that is a feature column names, and also I stored the value that is need to be predicted, that is what we want to predict, that is y. This is first step. Second step is I split up entire my data set into training data set and also test data set. In order to do this, we have a module that is from sklearn model selection. I import this one, train test split. So by using this method, I can split that entire data set into 4. So here assume that this is my entire data set. What I do, so I have done this. This is your features and this is your target function. So this entire feature is called as X and target function is called as Y. So what I do, I want to split my entire data set. Assume that you have 760 data sets are there. Instances are there in your data set. I want to divide this into 2. One is with respect to training data set and with respect to test data set. This is your training and this is your test. So this is how we divide our entire or split our entire data set into 4. This is with respect to X train and this is with respect to Y train. Similarly, this is X test and this is your Y test. So to split up this entire data set into training and also testing, we are going to mention what is the size of the test data also. Here the test data is 0.33%. So out of 100 instances, I allocate 33 instances are the test data and 67 instances are your training data. So this is how I split up. So in order to get the values, means how many training values are there or training data are there, I use this statements. So this is a second part. A third part is with respect to I want to train my model by using your training data. So which model I have picked up? I have taken Gaussian Naïve Bayesian model, or it is a classifier which is used on training data. So I use Gaussian Naïve Bayesian dot fit. What you are going to use? You are going to train your model by inserting or by giving two values. One is your features and also your target value. So here x is nothing but features and y is nothing but your target value of what? Of training data. So what are the this part belongs to, or this can be said as x train. Yes, we have given, and also this is your y train. So these are the two things that what we use to train your model, and by using this Gaussian Naïve Bayes we try to predict our test data. What you are going to predict? This is the prediction that what I want to predict. So this is x test and y test. By using your predictions x test, I just identify what is the target value. So this is your fourth step. And fifth step, here I'm using some of the matrices for understanding what is the accuracy and what is the precision and recall. So in order to derive what the value, that is accuracy value and precision value and recall value, first thing is I need to draw, or I need to get what is the confusion matrix. So confusion matrix will give you the quality of the output of that particular model. So in order to get that, how do I use the statements? So I use a matrix dot confusion matrix, y test, and also predicted. In the predicted, what you have given, x train, by using that you are going to predict, or you are going to get the confusion matrix. Similarly, I use what is the accuracy score and precision score and recall score. I will explain you in detail how to derive these recall, precision, and also the confusion matrix in detail. Let's see what is the probable output of this program. So you can see this is one of the output of my particular instance. So here the total number of training data what I have taken means I have a data set which is already shown that out of that 514 are your training data and 254 are your test data. So along with this, it's based upon this I have derived my confusion matrix. So confusion matrix, based upon this confusion matrix, I identified what is the accuracy of your model or classifier. So for this training instance, based upon the confusion matrix, I have received the accuracy is 0.7322. So it means that the accuracy of the model is around 73.22%, and the value of the precision is 0.59, and also the recall value is 0.623. So this is the output of your program. So let me explain how you derive or how to identify this accuracy value and also precision value and recall value based upon the confusion matrix. So let's see what is the confusion matrix is. A confusion matrix is a n cross n matrix which is used for evaluating the performance of a classification model, where n is the number of target class. See, this matrix compares the actual target values with the predicted by machine learning models. So this gives a holistic view of how well our classification model is performing and what kinds of error it is making. See, let's see an example here. Here we have a problem, a classification problem, which is of a binary, Means we would get, for a binary classification problem, we would get a 2 cross 2 matrix, which is shown here. Our target variables has two values. One is positive and also negative values. This column represent the actual values. Column represent the actual values of the target variables, and row represent the predicted value of the target variables. So let's understand some of the terms here. One is true positive. What do you mean by true positive? It is labeled as TP. The predicted value matches the actual value, then we call it as a true positive. Means that is actual value was positive and the model which is predicted as a positive value, then we call it as a true positive. Similarly, we have a true negative, TN. So the predicted value matches the actual value, which means the actual value was negative and the model predicted as a negative value. So the next one is false positive, FP. Here the predicted value was falsely predicted and the actual was negative, but the model predicted as a positive value, and this type of error is called as a type 1 error. So next one is false negative, FN. So which means that the predicted value was falsely predicted, which means the actual value was positive but the model predicted a negative value, and this is called as a type 2 error. So we have some other terms, that is a recall, precisions, and also the accuracy. So what actually precision is? Precision tells us how many of the correctly predicted cases actually turned out to be the positive. This is what it is, precision. And recalls tells us how many of the actual positive cases we are able to predict correctly with our model. So let's see with the first term, which is accuracy. What do you mean by accuracy? Which is, accuracy is the most intuitive performance measure, and it is simply a ratio of correctly predicted observation to the total observation. So one may think that if we have higher accuracy, then our model is best. Yes, of course, accuracy is the great measure, but only when you have symmetric data set, whereas where the values of false positive and false negative are almost same. And the formula for accuracy here, which we can see it as TP plus TN divided by TP plus FP plus FN plus TN. So this is the formula which is used to identify what is the accuracy. Similarly, we have an for precision. For precision, it is a ratio of correctly predicted positive observation to the total predicted positive observation. So here the formula you can see here for precision, TP divided by TP plus FP. So you can see this one. So by using this formula we can identify what is the precision is. And next one is recall. See, recall, sometimes it is called the sensitivity, which is a ratio of correctly predicted positive observation to all the observation which the actual class is yes. So the formula which is given as recall, that is TP divided by TP plus FN, identifying the recall value. See, this precision and recall, which is useful measures of successful of predictions when the classes are very imbalanced. See here, precision is a measure of result relevance, while recall is a measure of how many truly relevant classes are returned, where high precision relates to low positive rate and high recall relates to low false negative rate. So when a system with a high recall but a low precision, which may return many results, but most of its predicted label are incorrect when compared to the training label. Similarly, when a system with a high precision but low recall, it's just an opposite, but that is returning very few results, but most of its predicted labels are correct when compared to the training label. So these are all the basic information of confusion matrix, and also some of the performance matrices, that is accuracy, recall and precision. So we shall take one example and try to solve that example, and we shall compare with our program. So let's consider a simple example here. This is the confusion matrix where it consists of some values here. What is the formula for precision? That is TP divided by TP plus EP. You substitute the values here. 1 as a TP divided by 1 plus FP. FP is nothing but 3. So you receive the value as 0.25. Similarly for the recall, TP is 1 and TP plus FN. FN here the value what we have 0. Substitute the values and we receive as 1. And the accuracy is TP plus TN divided by total. Total is nothing but here we can write it as in gender, that is TP plus FP plus FN plus TN. So you substitute, or you can see this one, all the entire values summed up, and you can write it here 5. So 1 plus 1 divided by 5, that is 2 divided by 5, and you receive the values 4.4. This is how we calculate the value of precision, recall and accuracy. So this completes the program number 5, and in the description link I have given you the link for downloading the program and also the data sets and also the basic knowledge regarding your program, which is documented in the form of PDF file. You can also download in the below link. So thank you so much.